Good afternoon, everyone. Hopefully everyone can hear us okay and see the screen. We're just going to wait another minute, just so a few people are still signing up or signing on to the webinar at the moment. Please message us if you've got problems with audio or with visual. Okay, we're going to start. So, good afternoon, everyone. Thanks for joining today for this afternoon's webinar. As the title suggests, this webinar is really aimed at talking about cybersecurity in the field of engineering and looking at things like Industry 4.0, which is also known as the fourth industrial revolution, and the threats that that's introducing from a cybersecurity perspective. So we know that industry and engineering are changing. You know, there's sensors deployed all over organizations, collecting and collating data, which is sent back for real-time analytics. So there's really clear benefit in bringing the physical and digital world together to harness the benefits of that movement. Everything from predictive maintenance in transportation to smart cities, advanced manufacturing and production lines, and of course things like autonomous vehicles are coming up now. So the upside for this technology and convergence between IT and operational technology is very clear and something that should be harnessed. But just as we did with the internet and the digital age, what we don't want to do is sleepwalk into a situation where we are taking on this technological advance without thinking about the security implications. So this webinar is really going to talk about a bit of background, what's happening, what is Industry 4.0, some examples of, what that in practice, and also the potential risks that brings to organizations who are embracing that technology within their organizations. And then we've got some video content to look at the view from a chief engineer from Altran, and then we'll conclude things after that. So a bit of history. We are no longer just a headquarter. Companies are no longer just a headquarters in a city, so it's not just a single office. Hugely interconnected with third-party suppliers, with business partners, with our shops, with our distribution centres. There's connectivity all over the place, and obviously with the IT age, that brought its own threats and security issues. We also interact very differently with our customers through different omni-channels, through websites, through call centres, through online shops and e-commerce. So the world has changed, and we saw that with the advent of the internet and businesses taking advantage of the benefits that brings in driving additional revenue. And then we began to see a creeping up of legislation coming in to try and address the security issues that were brought in by the use of the internet within business. And then finally, in terms of personal information and the processing of that information, we have a piece of legislation in GDPR that actually has really made a difference. It has made organizations have to take privacy seriously, but it took an awful long time to get there, and there was a lot of damage along the way, a lot of incidents, and a lot of loss of data. So what we now have as well is the embracement of the fourth industrial revolution and the implementation of things like the Internet of Things and the industrial Internet of Things into warehousing, into manufacturing, into smart factories. And there's a real risk that if we don't apply the same principles that we've learned over the last 20 years of the internet, that we could be sleepwalking into a similar disaster potentially. So it's really important to think about cyber in the context of this change. A very quick slide on IRM, not intended to be a sales pitch, but it's really just to talk about us and our evolution from a very, very technical outfit back in 1998 when we were founded, and moving through the evolution into risk management, and then finally as a software company. But really the purpose of showing this slide was to talk about the acquisition process we went through back in 2017. The interested parties then were all the usual suspects that we expected to be involved. People like, large IT outsourcing organizations, IT consultancy organizations, other cybersecurity businesses, the big four consultancies. But also what was really remarkable about the people expressing an interest was there were an awful lot of organizations that operate very, very prevalently within the engineering field. And that spoke volumes for us, really, in terms of the fact that there really is a need to address cybersecurity within engineering. So just want to have a look at some of these challenges, but let's hear a bit about Industry 4.0 and the fourth industrial revolution and what it's all about. We've got a short video clip here from the World Economic Forum. Okay, so I hope people could see the video okay there. I had some feedback that perhaps that wasn't working, but anyway, so it was really just to give a bit of background about the changes that we're seeing with the fourth industrial revolution, with the implementation of Industry 4.0. And Industry 4.0 is really about taking the physical and then overlaying the digital onto the kind of physical environment. So you establish a digital record, you capture the information from the physical world, and create that digital record, and then you start thinking about how you can connect things. And it combines, things like the Internet of Things with relevant physical and digital technologies. Lots of examples: analytics, robotics, high-performance computing, artificial intelligence, all going into this realm. And it's a big leap between physical to digital to start driving Industry 4. But of course, in the background, there is also this threat and the real risk of cyber becoming a threat to impact the implementation of Industry 4.0 and the way organizations are embracing the benefits that brings. So wanted to talk through a few examples really and the potential risks within Industry 4.0. The first one around digital supply networks. Well, this is about having constant data sharing between digital supply networks and vendor management, and of course that means real-time interconnectivity. The benefits are really clear. If I'm an automotive manufacturer and my supplier can automatically see that I'm running low on a certain product as part of my supply chain, they can automatically send additional stock and make sure that I never run out. The benefits are great. There's huge benefits of automation within digital supply networks. But as always the case, when you start to connect things together and there's a lot of interconnectivity, there are ways to exploit that and attack it. And the disruption that could cause is quite significant. You can imagine that if I was to disrupt the supply chain to an automotive organization or manufacturer, that could cause downtime in the production line, and as a result, cost millions and millions of pounds in lost revenue. So we've really got to think about building security in from the outset when we're going to take advantage of the real benefits of implementing digital supply networks. The second example is around smart factories and the enhancement that digital can bring to automation within the factory environment. Even the concept of unmanned sites where you're connecting together all your systems, including enterprise resource planning systems, manufacturing and supervisory control systems. Massive benefit. Also in a manned environment where you're getting benefits through automation and the use of digital technologies, the impact from a cyber threat there could be catastrophic. It really could be a health and safety issue. It could be loss of life. And within a factory, there's real imperatives around health and safety and of course the production and process resilience, because downtime within a factory is costly and something that needs to be avoided. And on that point, this convergence between IT and internet technology and operational technology, where often the operational technology is a very legacy, outdated system, brings real risk when you're bringing it into internet-based threats. The final area to talk about is really connected objects, and this is a really massive area in terms of everything from the Internet of Things and the industrial Internet of Things. But you think about all the sensors out there in smart factories and advanced manufacturing, and those sensors need to be talking to each other in the right way, in a way that the integrity of that communication can't be impacted by a cyber threat. So there's big concerns around cyber threats impacting availability and integrity of the physical process through connected objects. And also this plays into the data protection area, where some devices may be sending personal information across a network and to automate billing, for instance, and that can be exploited by attackers. There was an example recently about the Hive smart metering technology, where it was sending personal data in clear text across a network. And we're deploying commercial off-the-shelf products that don't necessarily have security front of mind in the design of those products. So there's real dangers here. And whilst the benefits are clear and they're huge, there's also huge potential downside if security is not considered in the right way when embracing this new technology. So I just want to talk around a specific example on automotive as well. And if you think about modern vehicles and connected cars, the amount of technology that's now going into a modern vehicle is absolutely enormous. Altran and RM play a big part in working within the automotive industry and driving some of this change and some of the benefits of this change. But what that means is an increased attack surface on something like a car. So I got some figures here. In 2014, there were 85 million new light vehicles shipped, and that includes cars and light trucks. The forecast for shipped vehicles in 2020 is 100 million. Now, in each modern, advanced, connected vehicle, there's currently about 60 to 100 sensors, and that's projected to increase to about 200 by 2020. So you can obviously do the maths. It's going to be about 20 billion sensors deployed in smart vehicles by 2020. And that's an enormous attack surface for people to go and try and exploit. So what's really important, again, and you're going to hear me say this a lot, is about security by design, by building security in from the outset and making sure that we don't make the same mistakes that we made in the internet age, and that we apply the right principles and the learning from that time into this new advent of technology being used in an industrial setting. If we talk about really the scale of this as well, it is absolutely enormous in terms of the number of devices that are being projected to be deployed around the world to take advantage of this change, this industrialization, this use of digital to enhance engineering. The figures are massive. Some are larger than this. I think Gartner say by 2025 they're talking about 50 billion IoT devices. And what's really interesting here from a cybersecurity point of view is that there's a bit of a paradigm shift for the attackers, So if you think about attackers in the internet age, they were exploiting in a large part the interaction of humans with technology. So through phishing emails, we're tricking people to click on links, and that interaction with technology is being exploited by criminals to monetize, and to get, to defraud people. In the IoT world, it's completely the opposite. What the attackers are exploiting is the complete lack of human intervention. So these are dumb devices sat on the network, and you can communicate with and use them, and very easy to attack. And often we're seeing, particularly in the IoT space, that they are set with default credentials, they're set with default security settings, or a complete lack of security settings, and they are very, very easy to compromise. Attackers have already taken advantage of this with things like the Mirai botnet, where they managed to compromise millions of devices, including smart fridges and household devices that are on the internet, and use those to launch a denial of service attack against a major internet service provider in the US. So as this number grows and grows and grows, the manufacturing of these devices needs to catch up with the security implications and the cyber threats that are going to be thrown at them. And just to put things into context, we've got an interview here with Charles White, who is CEO of IRM, and he's going to talk about really the challenges around the convergence between IT and operational technology, and the risk that that brings.
For most large organizations, they played a little bit of lip service towards cybersecurity. But in today's market and today's world, we now have very robust legislation that demands that organizations take cybersecurity seriously. And as we therefore move into this new digital revolution, we find that we have complex frameworks, not only around protecting personal data in GDPR, but also around protecting items of critical national infrastructure and critical importance under the NIST framework. So today, we just have to be sure that we don't fall foul of some of the pitfalls that we fell foul of 20 years ago as we were looking at the pure IT cybersecurity market. And the pitfalls that we fell foul of then was not really understanding that we needed to embed cyber as part of our transformation. Everybody probably listening to this video will have had some reference at some point in their job where people are talking about digital transformation. Digital transformation is happening, but the most critical word in there is not per se digital, it's transformation, and it's transformation change. Many of the operational technologies that we see at play today are 30 years old. They haven't been upgraded for 30 years. There was no concept of connecting anything to the internet. There was no concept that pumping stations would require IT that was going to be connected remotely in order that people can monitor them from monitoring sites. There was no concept of the fact that aeroplanes would send constant signals down to Earth base stations to tell them how they were flying. There was no concept of the fact that water meters would become smart meters and electricity meters smart meters. So the whole of the digitization has moved into a new era. And that has meant that we now find that the IT and computerization teams that were operating 20 years ago are now coming face to face with those people that are operating in the more traditional engineering domains and disciplines. And we see sometimes a slight clash of cultures between the two. They go at very different paces, they have sometimes different agendas, but very much what we know and what we see is that the traditional engineering domain today is now adopting IT and cyber and digitization as a key platform to change and to progress and to transform. If we just take a couple of really simple examples, if we go and look at the mass production car of today that might be available with lane assist and lots of parking sensors and all the other great gadgets that we have. For many of the components that are delivered to go into the production line, they will come with more lines of code than would have existed 10 years ago on the largest, most complex of e-commerce platforms. And so now we find that there is no real testing or cybersecurity reference to those lines of code because they're embedded in a product that's on a bill of material that goes into a production plant. If we take another great example and look at, following the automotive analogy through, and look at autonomous cars, we now find that there are challenges with what if we get completely driverless vehicles? How is the IT world going to be able to comprehend and deal with the prospects and principles of sending signals to track a vehicle when it's flying at 100 miles an hour at somebody? How are we going to have communication protocols that are quick enough to be able to deal with that? So not only does the digitization and the new world bring with it a whole raft of new and exciting opportunities, it brings with it a whole raft of new and difficult risks.
Okay, so yeah, a short interview there with Charles, who's our CEO. Okay, so if you talk about the current way of thinking within information security and cybersecurity, we are very focused as an industry, in the InfoSec industry, on data, because in the IT world, it's all about data and the movement of data. So our traditional approach of confidentiality, integrity, and availability, perhaps bolting safety on the end, is not really going to work when we talk about Industry 4.0, when we talk about the convergence between OT and IT. So we need to rethink how we approach assessing risk from a cyber perspective in this new world. So looking at the engineering approach, when you're talking about automation and advanced manufacturing and smart factories, etc., safety is often the most critical risk and consideration that needs to be focused on. So we need to think about how a cyber threat might impact safety. Secondly, we need to think about perhaps reliability. So reliability of the production line, and as we were talking about earlier, in terms of the fact that any downtime costs a vast amount of money. And in the same way, how that would then impact on productivity. Integrity is also important as well, because the data in things like digital networks, digital supply networks, is going to be really critical. And if people can compromise that integrity of data, then that's going to be a massive issue. I mean, operational technology is deterministic, so it makes something happen. So whether that's the emergency brakes overriding on a train, or whether it's a valve closing if the temperature gets too hot on a blast furnace, it's deterministic in its nature. So we can't treat it in the same way that we treat an IT system in the traditional sense. So we need to think in a different way and approach things differently as the IT and OT worlds converge, and make sure that the way that we assess risk has been adapted in the right way to tackle this new landscape and the new threats. So there's a real need for the cybersecurity industry to change how they do things. And of course, sometimes things go wrong. We've got the self-driving autonomous vehicle that killed a pedestrian recently, not necessarily linked to a cyber threat, but of course, a cyber threat could be the cause of something like that if security isn't built into automotive in the right way. Other examples of where the convergence of IT and OT have been exploited. The Ukrainian power grid was taken out basically by a state-sponsored attack a year ago, in terms of exploiting that operational technology and IT convergence. It's believed that there were IT systems linked into the operational technology which were exploited. They provided a route into the grid, and attackers were able to shut down the power grid for some time and take control of the power grid. Again, in Germany, there was a steel mill with a massive blast furnace, and by the exploitation of a traditional IT system, by sending a phishing email into the corporate environment that operated the blast furnace, because there was a connection between the IT and the OT, attackers were able to get into the operational technology systems that ran the blast furnace and cause real havoc in Germany. And we also know that based on some of the intelligence coming out of the Department for Homeland Security in the US and the National Cybersecurity Center, that there is more and more state-sponsored focus on industrial environments and critical national infrastructure. So, attackers are very much ready to go and exploit this convergence between operational technology and IT. And we're already seeing some examples about this. So what can be done? Well, education is absolutely critical here. So the engineering world needs to be educated in cyber threats. You can't treat a car as a business network in the same way, or a chemical plant as the same way as an IT network or a credit card database. This quote takes that from Professor Tim Watson, who is part of the Warwick Manufacturing Group. He's the Professor for Cybersecurity at Warwick University, with whom we have a close working relationship. So one of the ways we can start addressing things is by driving education around cyber threats in the engineering context. And work needs to be done to make sure that courses in engineering, etc., reflect this new threat, this new problem, with the convergence of technologies and the drive of automation within industry and engineering. We hear all the time from the National Cybersecurity Center, from UK government, about the endless threats that are out there. And whilst most of the headlines have been around compromise of corporate environments and the theft of data, nowadays we're seeing more and more examples that we just touched on in terms of attacking of critical national infrastructure systems. And Charles mentioned in the video around new legislation that's been released by UK government, like NIST, which is focused very much on tier one providers and looks at utilities and the energy sector and areas like that, where they've really got to up their game from a cybersecurity point of view, because it is known that that is an area deemed to be relatively weak and easy to attack. So people are moving away from possibly from corporate networks and looking more at engineering environments and industrial environments, because they see that as a good place to go and compromise systems. And I encourage anyone on the call to go and have a look at the US Department for Homeland Security and have a look at their recent publication and alert on the increased amount of attacks on critical national infrastructure organizations and the energy sector. So we can see it from intelligence, and we can see it from exploitation and from the news headlines. In addition, the legal and regulatory environment needs to catch up with the threats. If you go back to my example at the beginning of this webinar, we were talking about the internet age, where it took far too long for us to update legislation to actually have an impact on how organizations have operated. The Data Protection Act was still published in 1998 for 20 years, until now, when we've released the new Data Protection Act to 2018. And it took 20 years for us to amend the right legislation and to make it impactful, that businesses would actually start to pay attention. We can't let that happen again, and we can't let that happen particularly within the engineering environment and the industrial world. Possibly, you could argue that the potential impacts within engineering and in the energy sector and utilities could be catastrophic and way more serious than theft of data, because it could result in massive health and safety issues with loss of life and potential impact on the day-to-day running of the country in terms of the critical national infrastructure organizations. So just moving on from that example, we've now got another video, and this is one of the chief engineers for Altran Group talking about his perspective on the cyber threats that he's seeing within the engineering world.
So in terms of the wider industry, whether it's aerospace or rail or automotive, my belief is they're all facing very similar challenges. Is that, again, a lot more software is being downloaded into these products, which means it's great because you can get additional data out of them, and data helps improve the productivity and make the efficiency of the operation. However, there is a threat with that, is that you are liable to attack. So somebody, if they knew what they were doing, can get into those products. And what I mean by that is that the traditional approach of mitigation is that it's behind a locked cupboard, or somebody has a password, a unique password on their laptop. However, that is not secure, we know that. So there's got to be a different approach to thinking about the safety of the products. In terms of who's furthest forward in all the verticals, I would say automotive, because of the way they bring in new technology in at a very rapid pace. Especially with hybrid electric technology, you're bringing more electronics into your products, such as the car. In the future, your car will be sitting on the drive. We're already experimenting with this, where information is being sent from the cars in real time to some of the OEMs to understand the performance and the operation of the car. In the future, the Formula One type technology will land in the traditional consumer, in that your car will be optimized, your latest software will be updated as soon as you drive back onto your into your home station, such as your home base, or even when you're driving along, we'll be able to optimize the car. And especially with the increased connectivity that's going to go off with automation and driverless cars, that's clearly where there's going to be a biggest increase, and I think that's why they're probably furthest ahead at the moment. So in the factory, a lot of the big manufacturers are automating their processes, bringing in robots. In their own right, that's fantastic. The big drive is to improve manufacturing operation. The more we bring in machine learning and artificial intelligence and analytics into the factory, means that we're introducing more and more software. The factories start to run themselves. The threat, therefore, is that unless you take full account of the cyber threat, there are potential vulnerabilities in the systems that the factories are operating with. If you can get into a factory, then you could cause elements of disruption, whether it's to stop the production line completely or to do random things and introduce randomness into the manufacturing process that then causes disruption or issues with the end product. So as a kind of chief engineer that kind of sits across the wider business, I think for me one of the key things that I'm seeing is that when engineers come out of their standard education, out of university, they're very much trained in how to understand the traditional safety risks associated with the products. What they're not necessarily considering are the safety threats associated with a cyber threat. And we're seeing this in a lot of the documentation. So the way that the internal processes that industry use has to change means that we've got to include the cyber threat in addition to the traditional safety threats that most engineers today are trained to utilise.
Okay, yeah, that was just hearing from Graham Upton, one of our chief engineers at Altran. So the last bit here is to think about how RM's had to adapt really to address this new world, this new environment, the new challenges. Our core skills around penetration testing, we've had to adapt that to focus on industrial systems and to adapt our methodology to be different in how we go about testing corporate IT systems or web applications. A much more different approach has to be taken in terms of looking at the architecture first and understanding the architecture. There has to be a lot more detail up front prior to doing any active testing on sensitive systems, because as I've alluded to, downtime is simply not an option, and we have to adapt accordingly. Risk analysis and how we go about risk. Again, I talked about confidentiality, integrity, and availability are the key sort of areas that we focus on when we're looking at information risk and data risk in the IT environment. But when you're in an industrial environment and operational technology, you need to think about safety, you need to think about availability and productivity and the potential impacts to those. So, we've had to adapt the way we deliver services and deliver those services to our customers appropriately to make sure that we consider cyber threats in an industrial context. And again, within our Synergy software platform, we've brought in these standards that are particularly relevant to the management of risk within industrial environments and industrial organizations, and had to adapt that accordingly. And it's been an interesting journey. So just going to come up with some summaries. I've already talked about the fact that we've got a lot of learning to bring to the table in terms of what we learned from the internet age and addressing cybersecurity threats within IT. That was focused very much around data. However, one of the principles of security and safety by default, or security by design, applies in the industrial context as well. So for industrial Internet of Things and devices and sensors and the way they communicate, all these things need to be secured by default. And I think what we've got at the moment is a problem where lots of people are deploying the technology to take advantage of the benefits, but not necessarily thinking about the threat that that might bring into their organizations. So, we can't just assume that commercial off-the-shelf products that you're going to deploy into your environment to drive automation are necessarily going to be secure, and we need to address that. And that goes for the manufacturers as well, and incorporating security at the design phase, building on proven security best practices, and making sure that their products that they ship into the market are secure as well. I think we've still got a long way to go in terms of making sure that some legislation or some regulation around that will drive that secure by design in the manufacturing process. Dealing with legacy systems, we see, in production lines, we see NT4 boxes, Windows NT4, massively outdated systems that aren't touched because they're believed to be air gaps. But as they're coming online and being connected to internet-based systems, well, they can easily be exploited and attacked. So there needs to be a way of addressing legacy systems and moving into a more modern environment. Ring fencing those devices and controlling traffic that connects in and out of those environments is really critical as we migrate systems to more modern technology. Consider controls. So it's all about reducing risk, and that principle still applies within the industrial context. It's about prioritization of security measures according to potential impact, and then coming up with a sensible control to reduce risk. So the same principles that we apply in the IT world can be applied into the industrial world to a certain extent, and we need to make the most of the learning from those years. And building for the future, just making sure that environments are secure and that we don't continue to drive more insecurity in the engineering environments that we operate. So that draws the webinar to an end. We've got time for some questions now. I believe that you can post some questions through the messaging system. So we've got time for a few questions. Okay, we've got quite a few questions coming in, so we'll address as many as we can within the time frame. First question is, do you think government is doing enough to encourage manufacturers to prioritize cyber? The answer is not yet, but as with all these things, I think government kind of goes at the pace that it goes at. It doesn't release the legislation that's effective enough, quickly enough. And again, going back to that example of data protection law, 20 years it took to get to the point where the legislation actually meant something to a business, that they had to really pay attention to what they're doing. The UK government has recently released a paper under the Department of Culture, Media and Sport, I think. Quite how it's spelled, I don't know. But they have provided some guidelines on security around internet IoT devices and hardening those systems and devices. So there is some work being done. There's good guidance coming out of US government as well, but it needs to be mandatory. There needs to be legislation to really drive that change, I think. So still a long way to go is my answer to that question. Okay, the next one. Do you think enough is being done by board members or executives of large organizations, and do they understand the seriousness of cyber? Well, I think boards do get the seriousness of cyber. You'd have to be living in a cave for the last 10 years if you hadn't seen anything about it, frankly, with all the news headlines. But so boards, I think, do understand it. But if they are manufacturing devices, they need to really drive that down from the top down to make sure that their organisation is doing security by design and making sure that they're doing security by default. So there's probably not enough being done, particularly in some organisations, and it needs a lot more focus. But most boards do have a reasonable knowledge and awareness around cybersecurity, but probably more on the the data breach side of things, as opposed to the impacts that we've been talking about today within industrial organisations and industrial settings. Yeah, we've got one more. So what's your advice on upgrading legacy systems in production lines without impacting business? Yeah, okay. So that's an area that Charles alluded to in the interview, where he was talking about the fact that these systems have been deployed for 20 years, 30 years. They were never really designed with security in mind, and they were never designed to be in production for that long. And as we connect them to internet-based systems, these threats are appearing that can cause real issues. So, I mean, a staged approach is probably a sensible way of doing things. What we've helped organisations with is really creating a walled garden around legacy infrastructure and legacy devices, putting tight monitoring and control on traffic going in and out of those environments, and making sure that you do the right things in terms of reducing risk in there. And whilst doing that, you can start to build new environments with new technologies that could potentially be migrated over time. But in the near term, if you are converging IT and OT, the thing to do is to create that network segregation, to monitor closely, and to control traffic inbound and outbound from that environment with great control. So we haven't really got time for another question, so we're just going to draw the webinar to a conclusion now. There's a recording of the webinar that will be sent out tomorrow, and also we are going to be running an event in 2019. I think it's March 2019, called Risky Business. We'll be running a survey, which would be great if people could participate in that survey, because we'll publish the results of that at the conference. And we will share a copy of the slides. And also, if there's any questions that we haven't addressed this afternoon, we'll send out a Q&A crib sheet off the back of this session. So thanks everyone for your time. Have a good rest of the day and a good afternoon. Thank you.